Today, what we discussed basically a very simple concept, and the concept was rule-based learning, or should you have uh, dynamic learning? That is, the rules are automatically formed, right? And we just, I'll just take you through the same theory for 5 minutes, and then we'll again come back and jump to it. Yes. All right. So if you see, in we have been seeing two kinds of things, that is rule based, and you know lots and hell lot of applications still work on this same rule based application. And then we go towards dynamic weights. We go towards dynamic weights, and there are lots of advantages that we get when we switch towards dynamic weights versus rule based. Obviously, for smaller applications, obviously, if you have 7, 8 rules very well defined, you can go ahead and write down these rules and it can follow those rules. But however, when you have like 300, 400, 500, you don't even know how many rules are present, then obviously dynamic weights is something that we should be using, right? And in dynamic weights, what we saw, the formula is very simple actually. You have x here and then you have something y. You have an x variable and you have an y variable. This is one variable only. As we increase the number of variables, so does number of learning parameters, that is the weights increase. So x into w, what happens? It produces y hat, and then what is the difference between y hat and minus y? Becomes error. This is the error, the difference. And then whatever the error is, basically we will, based on this error, we will again update our weights. We will update our weights. So we will have new w1, and idea being that after this x1, x2 should be multiplied to this new weight, and we should have new w2 hat. And again we will calculate the error. Again we will calculate the error, and again we will update the weights. Again we will update the weights, right? This is the whole idea from where this complete AI began. Initially, it started with a very simple idea, but gradually the same idea was developed into much of the things. Uh, complex things in the sense, what they started doing is that this all theory, what I'm trying to tell you, is you can consider this as one cell, or one, whatever you can call it, like how do you understand it? It can be one cell in which this complete calculation is going on, right? If you come from like programming background, then it can be one small class or one small function, right, in which this whole process is going on. And if you are like from a non-programming background, then you can understand that this is like one process, or there is one box, right? There is one box in which this whole process is going on. This whole process is going on. And then how did they make it more intelligent as of now? Basically, by multiplying this box. These processes, these boxes were multiplied, in the sense now there are approximately, they've started playing with like 1 billion of such cells. In future, we will call it neuron. In future, we will call it neuron as we go towards neural networks, inspired from brain but does not mimics brain. We do not know how brain works as of now. It is inspired from brain, that this is, yeah, from inspired, we saw the structure of the brain and we saw that this is one way it could be interacting with each other. uh, so these millions and millions of cells, and these millions and millions of cells, they are stacked against one another, and they have their own set of weights, They have their own weights, W1, W2, W3, so on, W1, W2, W3, and so on, so on. They have their own set of weights, and then they keep on interacting with each other. As a result, what you get is they learn. I mean, they have learning. They preserve a learning that is huge, and that becomes I mean, what we feel as the intelligent part. Right. As of now, first we will have to understand the part one only. Part one is as simple as that. Again, we will have an input. We should have some data here. We will have an input. Now, this input can be, today we will see various kinds of inputs, right? We will have simple input. We have been playing with the temperature thing, and soon we will jump to more realistic example, right? We'll jump to a realistic example. We have input, we have temperature, and then we will have our model here. We will have our model, and then as we have our model, we will have our predictions. We will have our predictions. If the predictions are not up to the mark, they will be compared to source of truth. Source of truth means the real data, the real source of truth. They are compared to source of truth. If it is not, then it it should go to our the source of truth, the learning, that is whatever the error is there, that learning should go to our model. Model means set of weights. Set of weights. Now we have a new definition of model, or actually this is the final definition. The set of weights is my model. These set of weights can be, as of now we see, it can be a single variable, it can be a group of variables, it can be a vector. That is, it can be different collection of data. It can be single data, it can be multiple data, right? It can be an array, it can be a vector, and soon we will see that the collection increases. The collection increases, thus the more amount of learning it can keep. The model can keep more amount of learning. And this is what actually the weight is. This is what they call that we have trained our model. This is what the weight is. The optimal numbers where the input produces the optimal output is what the whole game is about. So we need to optimize weights, we need to optimize weights, so it calculates, so input is mapped to nearest output value, mapped to nearest output value. Again, just read this again. We need to optimize weights, optimize these weights. We need to optimize it. Optimization in the sense we need to keep on improving it. We need to keep on improving till the time the target is not achieved. Keep on improving, keep on improving, right? Keep on improving weights so that input is mapped to nearest output value. Input is mapped to, and then you remember my initial definition, that is, these models are mammoth size statistical mapper. Like I said, the whole idea is that I need a formula, I need a hidden formula, right? So if you do 5 into 3, you know the formula, hence you are able to say that it is 15, right? But let's say someone from Stone Age, he just discovered that something gets multiplied to 5, it becomes 15. I do not know what is that. Today you know that you, if you divide it, you get that, you know that relationship, right? But the whole point being that hidden part. So we know that two elements, element 1 or input 1 and input 2, are related to each other. They, you know that they are related to each other, but what is that relation we do not know. The whole hunting game is to find out that relational formula, that relational formula. If you are able to jot that relational formula via a set of rules, then obviously it will take less amount of time, and hence it is said that, first you should evaluate if your problem is small enough, If your problem is small enough, it can be solved by a calculator. Why do you need a computer to solve it, right? Why do you need to spend more money? Why do you need to like it will occupy space and everything. If your job is done by a calculator, why do you need a computer? But there are certain things that only computer can do, where calculator cannot replace it. So we'll first have to judge that thing, and then it is all about finding the right formula. It is all about finding the right formula, optimize, again, keep on improving the weights so that its input is mapped to the nearest output value. Like I said, it is not approximate. It is not going to be approximate. If, let's say, I'm trying to predict some temperature and temperature is 27.3, then it might be predicting 26.9. If this is predicting this, then obviously it is near. We are near to this. We are almost near to this, right? So this is considered as the right value. This can be considered as the right value because the error is very small. Or it may be that 27.4 is there and it may predict some 27. Or if it is 27.1, then obviously. However, if it is directly predicting 21, this is a wrong value. This is a wrong prediction. Then we cannot convince anyone that it is the right thing that it is saying, right? So obviously, 27.3 and 26.9 are somewhat near to each other, right? And similarly, 27.4 and 27 are also near to each other. So obviously, we can say that our model has been able to produce an output that is near to each other, and the whole theory that we will be studying, the various ways, the various kinds of neural networks, the various kinds of neural network. This is one theory, right? Obviously, we have these cells now, and each of this cell is like an individual box performing this whole process. Then, what we will see further, we will see that there are various patterns just to arrange these cells, and the output changes. You can arrange these cells into various different patterns and the output changes, right? And hence, like I said, this might be a very new logic to solve the problems, a new way to solve the problems, right? uh, and you can just arrange them into various formats. There are various architectures we will see, like we will see about CNN, convolution neural network, RNN, recurrent neural network. They are having the same basic structure. Neurons are eternal. They will always be there, right? Neurons is always the single most thinking cell, the simplest thinking cell. It is always going to be there. Just the architectures will change. There is going to be RNN, then there is going to be transformer on which all of the new models, that is your Gemini, Chat GPT, and everything is based upon. They are all working on the same thing. Just how they interact with each other changes. That formula changes. And I mean, there are a lot of things that we can control. There are a lot of things we do not even know how it is working. So, a very famous paper released by uh, Google and its first line actually said, "It works, but we do not know how it works. We came to this best results. Maybe, uh, I do not recollect the exact words, but this was the first line of the paper, and the first line said that it may be some divine blessing that we have arrived at this result." So a lot of times what happens when you keep on experimenting, you arrive at some results which logically you would not be able to arrive. If you keep on thinking logically that, okay, I'll be playing with it logically, then you would not be able to arrive on. But after experimenting a number of times and you thinking that, okay, and this was the first line of the most influential paper, which actually enhanced a lot of things in the existing neural network models and lots of things. So, like I said, I mean, we humans think that we can do this, we can do that. There is a lot complex that we do not even understand. And soon we will see that setup becomes so complex, this setup becomes so complex that we do not know what is going inside. That we do not know what is going inside. We only understand a little part of it. 6 months back, there was a comment from Anthropic team. Anthropic, the same team that releases Claude Sonnet models, and they are quite competitive models as compared to ChatGPT, Gemini, right? Quite good models. And they released a statement saying that we only understand a small part of how it is working inside. We only understand a small part of it. So, like I said, the reason being the permutation and combination of the values becomes so huge that it becomes really hard to understand what is going inside, right? But let's try to understand as much as we can. Obviously, when millions and billions of it grow, uh, tracking it inside becomes impossible. But yes, we know that how it is built. We know that how this mathematics is done and all of those things. Okay. So now going back to our demonstration. So this is what we will be doing. Going back to our first demonstration. Let me just switch back. We've actually made a lot of demonstrations and okay, let me first start with this one. So, okay, all right. So basically here again we have x1, x2 and x3, right? Now, if you see x1, x2 and this is my actual and this is my predicted, right? x1, this is my x1, this is my x1 value, right? This is my x2 value, this is my x3 value. That is, this is again, we are again at still at the temperature predictor. We are still at the temperature predictor, right? So what we are trying to predict is that we are trying to predict the next day temperature. Okay. So, and then this will be our y hat. This is my y hat. That is my predicted value. This will be my error that and error will be y hat minus y. Now you can square it. Obviously, you can square it. What happens by squaring? This is like a penalty. This is like a penalty, right? So whenever you are actually even training dogs, how do you do that? So when you are training dogs, when he does the right step, you award him something. When he does the wrong step, you put a penalty to him. This is even how normal brains work, right? Reward and penalty. If you do something good at a workplace, you are given a reward, or else there is a penalty. I mean, so this is the penalty. If you do it square, obviously, if you want to penalize more, then your penalty increases. Then your penalty increases. There is one very good video wherein a hen is taught using the same uh, like fundamental. So hen is taught what to do, what not to do, and if it is doing right, it is being awarded uh, with a stack. If it is doing wrong, I forgot what was the penalty. So yeah, so this is how they were teaching, and then hen finally figures out that okay, if I want good out of it, then this is the path I should follow. Same is for this model also. So we have y hat, we have error, right? And this is my actual and predicted value. If you see, my actual is not linear. It is this kind of data. My actual is this, and my linear is the green. Green is the predicted one. As of now, model has not learned anything. This is my actual. And how is my y hat calculated? Y hat is simple calculated. This is my y hat. So how is this y hat calculated? So y hat will be calculated. You see W1, so weight 1, that is I will have initial W1, W2 and initially they are 0, right? All of them are 0. So I start with 0 or you can start with any random number, right? Initially they are 0. So W1 into X1, W1 into X1, right, plus W2 into x2 plus W3 into x3, right? And you can assume that these are actually the weights of individual parameters. These are weights of individual parameters. You can, as of now, add a bias, right? Or you cannot, right? This is just an additional learning parameter. This is just an additional learning parameter, right? If you, we can also, as of now, we can escape it and we can just keep this formula. This will also work. It is not that this will not work. This will also work, right? Later on, we will see that what happens by adding bias, what happens by removing it, just actually smoothens out the learning. That's it. So this is the role of bias. That's it as of now. So W1x1 plus W2x2 plus W3x3. Now, what I do is I start and then update rule. What happens? This is updated. Y hat will be updated here, calculated, and then error will be difference of these two things, y and y hat. Let's see. Let me run it. One row is here, and error is here. Again, second row, third row. You see weights are getting updated, right? Error per row is y minus y hat, and update rule is basically, it is actually updating by multiplying it again with the error itself. So basically, how much, now there is one more important thing, learning rate. So see, try to understand, this is nothing fancy here. You just try to understand how much do you want to update your weights, by how many times, how fast do you want to update your weights, in the sense, just try to understand. If my learning rate is very small, let's say learning rate into whatever my error is there, right? Weight minus 2 e into x. 2 is basically in order to amplify that thing, right? 2 in the sense to, in order to amplify that thing. So basically learning rate into error will be actually updated into weights, right? So learning rate can be small. If learning rate is small, more learning will go into this weights, right? If learning rate is huge, uh, like more learning can go into, sorry, if learning rate is small, small learning will go into these weights. If learning rate is huge, more learning will go into these weights. Now, it is not always, I'll just explain you this learning rate also. We can actually see it visually here. Now you see it has started to learn, right? I'll just keep on doing it, and if you see, it is actually okay, it has learned, and it has learned. Now, we need to stop at some point wherever the error is minimum. We need to stop at certain point where my error is actually minimum, right? I will have to start at certain point. So I will auto run it and I see it is running, and it has stopped. So this is my actual versus this is my predicted. This is my actual versus this is my predicted. Now, if you see what I do, I remove this zero, right? I remove this zero and what happens now? It learned very fast. I mean, you see, there is, uh, it is learning very fast. Now, is it always, then we should always use some good learning rate now. But if you see what has happened, uh, it did not fit here very clearly. If you see, if you see this part here, if you see this part, it did not fit here very clearly. What it has done, it has fit here clearly, but it did not fit here, right? With high learning rate. With high learning rate, the updation was very fast. The updation was very fast, right? But what happened? Basically, it is trying to fit these values, right? Now let me make it 0 point what it was, 0, right? I will reset it and let me do it again. It is gradual, smooth, right? And somewhat better than before. It is gradual and smooth, somewhat better than before. What happens if I make it 0.02? It will be even slower, very slow. You see, it is very slow. trying to learn those small conditions of, but it did not fit properly. So you will have to experiment and you will have to find out your optimal learning rate, right? I'll reset it again. Okay, I ran some two epochs, and what it is trying, the whole idea is that, it is trying to fit to the predicted values as close as possible. It is trying to fit the predicted values. As the error has reduced, the error, lower the error, better it will be. Error means the difference between actual and predicted is your error. Now, if we go, okay, I don't have that thing here, right? I'll open a second demonstration. So yeah, the error is basically the smaller the difference between actual one and the predicted one, that is, the lower the error, better it is. The lower the error, better it is, right? So this is what is happening. This is the whole thing. We will keep on talking about learning rate everywhere. This is going to be till the end of this course. A very crucial thing what learning rate is, how rapidly the weights are applied or the weights are updated back, right, is the learning rate with respect to error, right? So all of these parameters have to be in a good state if we want our AI to perform good. Now let's jump to one more demonstration. Mm, 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 mm. Non-linear temperature weights.
Hey, Anand, one quick question about
Yeah,
learning rate.
yeah, yeah,
Uh,
yeah, yeah, yeah.
So, since learning rate is directly proportional to the error, right? I mean, because it
No,
impacts
no,
the
no, no. Learning rate is not directly proportional to error.
weights, right?
Yes, it basically the rate at which the error will be updated to the weights.
Okay. So then, how is it something like system calculates what optimal learning rate has to be there, or is it something based on our multiple iterations? We'll have to.
Based on
Yeah.
multiple iterations, we will have to calculate.
Okay, we'll have to calculate and feed it, right?
Yes, yes,
Okay.
exactly. There is, I'll discuss one few frameworks that are already there that works via optimization of these parameters that you can use in daily life also.
Okay.
Basically, even in daily life, you see a lot of things are all about finding the best fit numbers, right? That magical number that works anywhere, let it be anywhere. So there are certain optimization ways that we can use.
Okay.
Okay,
Thanks.
But then how do we determine what is the initial learning rate? Like,
initially we start with some random numbers.
okay,
Initially, we start with some 0.01 and then we try to run on a small sample. Let's say my data is very huge. Let's say my data is of 500 GB. Now, obviously, when I'm training 500 GB data, obviously, many of us will not be training that huge data, right? But let's say 500 data GB, and let's say the training time takes uh, like 2 weeks. And there are big models that take training time 2 weeks on big GPU farms. Then what we do is we take some small sample, we'll run on it, and we find that okay, if this is working fine, always you work on some test on some small sample. Let's say that small sample can be some 5,000 records or 3,000 records. So you will get an idea that okay, my data is actually quite working. These parameters are working fine on this small sample of data. Then you can apply it on the big one. So yes, I mean, somewhere we will have to start with some randomization and some hit and try. But always, like when we are dealing with the big data sets, we don't go and directly jump on those big data sets. We take a small sample of those data set and then we try to find out the best optimal parameters, right? And similarly, we have this one. And it is again the same thing. We have learning rate. We have this time we have randomized the weights. My weights are actually randomized. In the previous session, if you see, if I reset, they were zero. This time I have done randomization, randomize weight, randomize, random. Every time I click, this is something random. Then I will calculate everything. It is calculating everything, and let it calculate one complete data, that is one complete run over all the data is one round, and technically we call it epoch, right? We call it epoch. You might have seen, this is epoch. Epoch is one complete round with all the data, right? I can run it once more to bring my error down, right? I can, but let's see what my error actually says after this. Right, done, and my error has gone down. And then I can take some data to predict. Let's say I will take some data, some real data. Although the data on which you have trained, you should never test that data, because obviously that data it has already learned. You should always test it on some unseen data. So I can just take that if it is 28, and then it was 26, and then it was something 25 or 27, right? What is then it says that temperature tomorrow going to be is 27.196, right? So it has started to predict that what could be my actual temperature. And when I'm trying to, on my learning data set, only, when I'm trying to predict, this is the difference between my actual temperature, and green line is my predicted one. Green line is my predicted one. So this is the difference. Now if you see the difference here, right, it might be 27 and my predicted might be 27.5 or 27.7. Small difference will be there. It is not going to be accurate, right? Here it will be accurate. Here in this case, on this uh, like uh, edge, it is accurate. Again, on this edge, it is close to accurate. It is not. On this edge also there will be a difference of one or something like that, right? So this is okay. I mean, for our problem, this is okay. It understands that now if you have to add lot of conditions, there will be so many conditions already present, that if these many parameters are there and so and so. Now if you increase the number of parameters, obviously in next example that we see, we will increase these parameters. And as we increase these parameters, obviously what is going to happen, that the number of uh, the learning is going to be more complex, but the formula is going to be the same. We will be using the same basic formula everywhere, actually, just a more complex version of it, right? Now next, we jump on one more simple example, right? Like I said, we will be working on lot of examples, and this time, like I said, we will jump on, there is one more demonstration I would show you. How does the weights actually learn? Now if you see, now if you see this, okay, so basically what is this? This is my weight, and this is a 3D demonstration. If you see, this is a 3D, you can see it, right? Right, this is a 3D demonstration. This is where my weight currently is, right? This is where my weight currently is. And the idea of my weight is to find a stable position near to my predicted position. This is just a plane. This is just a 3D plane. And if you see, this is my learning rate and initial weight W1. And once I start learning, you see, oh, this is very small, obviously. Let me increase it, reset it. Oh, it is going again. Initial weight is this. I'll use this. Reset it. Okay. So it is actually, I just give me a second. So this red dot is actually trying to predict it. Now this is what is happening, right? What is happening basically when we start learning? So you see this, it starts experimenting. First error it has updated. Learning rate is 0.01. So it goes and says, and once it has gone, so see, this is a guesswork. When you update the weights, then what might happen? The next step, it might say that, okay, you have gone too far from the value, from the predicted value. It says, oh, is it so? Let me come back. So it will keep on oscillating around that value. It will keep on going forth, so forth, and it then ultimately, first it went too far, right? It went too far. Then it came here. It said, oh, again you are again far. It went here, right? It says, okay, you have done well, but you're still somewhat far, better than before. It went here. Okay, it said, okay, somewhat better than before, but still far. Then it went here. Then it went here. Then it went here. Finally, it settled here, right? Let's uh, see this thing again. Let's see this. Right. And if I reset, if I increase the learning rate, then what might happen? You see what might happen? Oh, learning rate has increased. It was just wandering more around the same point. This is our optimal point where we should be, basically the point where the, and you see, even it is still working. The it is still learning, but now it is not moving. It is saying that, okay, based on your data and based on the formula you gave to me, this is the best fit that I have. Like, we can reset it. Initial weights, smooth learning, I can keep the weight very low. What happens if we keep the weight very low? Okay, very slow. The red dot is still here. It will take a lot of time maybe. And hence, if your learning rate is slow, you might end up having a lot of time, right? It might take a lot of time. If your learning rate is very fast, it might be very fast, but you will not be able to find the right fit. And so it is working and working. I do not know how much time it is going to take. I will reset it anyways. I'll increase it a bit. When this is small, I guess. Again, okay, this time it has settled here, which is again very far from where it was settling earlier. We do not know this point is the optimal one or this point, which point is actually the optimal one, because obviously here we are not testing the data. Can reset it. Can I can play with more weights initialization. Okay, this time it has gone somewhere in the middle, right? So weights, sometimes weights in initialization also do a lot of things. Obviously, as we go forward, there are certain ways by which we can optimize our weights initialization. As of now, we are just doing it random. So as we initialize the weight, so here it is landing. And this is my error. Basically, my error should be minimal, right? Okay, done. Let me just now go to a different example. And different example is, what is my different example? My different example is somewhat uh, close to real life this time. That is, we will be again using the same thing, but the same formula, different data. First, we will see a simpler format of same data. Next, we will see a more complex format of same data, right? So idea is that, first and foremost thing, that what I want is, I want to predict the price of a house. This is again, the data set is present, very famous data set, house prediction data set, right? A lot of different programs are present to predict it. But if I want to predict the house, right? If I want to predict the house, right? First is, I will go through the Excel simulation, right? So that we understand things even better. One step, again, a practice point. We will understand this Excel simulation. And then second, I will go towards more advanced features. So basically, like I said, the better for calculating better prediction, what you have to do, first step is basically what are the features you are using, right? So as of now, I will just use simple features, that what is the total area of my house, total area of my house, and any other data I have, and what is the tentative age of my house, right? What is the how old is the house, area and age, right? Area and age. A simple example, right? This is for us to work on like the Excel, right? Area and age, and I'll give you this Excel. Don't worry. So you can sit back and use these formulas and work yourself. So area and age, we want to work on this Excel. So basically, then I have some original price, and I want to reach towards predicted price. This will be like our example one. As we go forward, I will include second more complex uh, data. More complex data in the sense I will have area, right? I will have age. I will have distance from the center. How far is the house from the center of the city, right? What is the distance from amenities? I mean, I can have some average calculations of distance from amenities, distance from amenities. Then what is the crime rate of this area? What is the population density of this area, right? So if you see, when we choose the right parameters, we can actually calculate the right prediction. We can have the right prediction, right? Obviously, this is going to be somewhat a toy example, that is not very close to real life. But when we see this one, prediction area, age of life, how much is it distant from the city center or from the center of the city, then what is the like distance from all of the amenities. If you want more, you can have distance from schools, distance from hospitals, and distance from supermarket. You can have three different columns also. And remember, all of this has to be in numbers. It cannot be in string. It cannot be in string. How do you convert all of this in numbers? Now, let's say if you have 10 different areas, you will have to name them 1 to 10, like area number 1, area number 2, area number 3, area number 4, and so on. Age, obviously, it is going to be a number, 20 years old, 10 years old, 25 years old, something like this. Distance from city center, again, this is again going to be 3.5 kilometers, 2.5 kilometers, something like this. Distance from amenities, again, it's the same thing. Crime rate, this is by default going to be the number, right? That it is having 2% crime rate, it is having 5% crime rate. And then what is the, this was basically a population density, right? Population density. So population density, again, it is again going to be numbers per square kilometer or per meter, whatever we choose. We can use that population density, that if 1,000, 10,000, something like that, right? So obviously, you can have more things like uh, how many corporate offices are present in this area, an average, how many corporate offices are present in this area, and the real uh, prediction or the house, if you see on many of the property websites, this is how they do it actually. This is the algorithm that works in the backend, and this is how the real prediction takes place. They might have more number of parameters which actually work down the line. As you like I said, you will have to understand the data first. So first first process is collecting the data. Obviously, let's say we are collecting the data in every 6 months, let's say, and then there might be lot many other parameters, and then based on that you can even predict that which area is going to be more uh, like where should you invest. Should you invest in this area versus should you invest in that area? Once you have that right information, your algorithm will be able to basically predict that area also, right? In which area should a builder build his house or his property so that they sell more, they sell really fast, basically the time, the reduction of the time, right? In which area should you buy any retail property or commercial property so that there are maximum chances to rent them out. Which area should you buy so that you have maximum highest ratio of rent to return, right? There are certain areas wherein the rent is uh, the property might be costly, it might be in a very good zone, but uh, the rate of return from the rent is low, while there are some areas the property is less costly as compared to the previous one, but the rate of return of the rent is really high, right? So these are the different parameters you will have to work on, and then basically you can have a model that can do the predictions and all of those things, right? So first we will start with a very simple one. Let me just start with a very simple one and just bring the Excel before you. Mm, mm, okay. House price prediction basic. So I have already prepared the data. Obviously, I have to be prepared with the data in order to demonstrate. So I will be using the same data, but I will be doing it from scratch so that we know that how it works. The idea is very simple. See, I can demonstrate any formula, anything on Excel, uh, right? Obviously, see, Excel has a limited capacity. So yeah, going down the line, we will have to use, uh, you know, we will have to use scripting because there are more complex formulas that we have to do, right? Here we have. This is very simple. But like I already said, this time my aim is to uh, differentiate that no, scripting is just to automate the logic, right? And hence, in last session, in last lectures, that is in the previous batch, I did not much depend on the Excel. But then what I realized that if the logic is there, then obviously first we should be able to replicate that in the Excel. And once we are able to replicate that in the Excel, obviously we can do anything around it. Okay, here we have square foot, bedrooms, age, and actual price, right? This is my initial data, and this is my actual price. Now, I should first try to find out, this is a comparatively easier data, right? That is, I should try to find out that is what is the relationship between square foot and actual price. So I can just go to my Gemini. Either I can just uh, select these two columns. I can insert. I can go to chart, insert, chart, and then I can have both of these charts ready here. This is the relationship that it says between actual price versus square foot. So it is actually linearly related. As of now, what my data is showing, it is linearly related. I can do the same thing from Gemini also. I don't have to do this. I can do the same thing, that plot chart of square foot versus actual price, right? Plot the chart. Okay, the same chart it did show me. The same chart it is showing me. This is the same chart that I have. That it is, these are linearly related. Okay, it is going to be easy actually. Comparatively, it is going to be easy. What is the difference between bedrooms and actual price? What is the relationship? Plot chart between bedrooms and actual price. Okay, the relationship is not very linear, but if you see number of bedrooms, and actually it is increasing this way. There are certain prices it range from 31,000 to 51, while there are certain 3 bedroom apartments also that are comparatively less. So somewhat linear, but not exactly linear, right? Somewhat linear, but not exactly linear. Okay, done. Got it. Noted. Third is age of the property. So obviously, I guess it will be inversely related, right? So relationship between and age and actual price. What is the relationship between age and actual price? Okay, it is actually inversely related. That is, uh, more the age, less the price is, right? Newer the property, obviously, but again, it is not very much linear. It is not that there is a straight line, right? There is no straight line. So obviously, sometimes putting all of these things into rules, even for this data, which is comparatively simple, putting all of this thing into rules might become somewhat tough. But what we will try to do, we will try to actually put all of this data into, in a way, the same weighted learning, so that we are able to predict the right prices using the rule that we have just learned. Right, close these things. Okay, all right. So first and foremost thing, I will have to insert new columns. I'll go with predicted price. I'll go with error. I'll go with squared error. And then, right, these are three things that I will need. Then I will have to define all of my model parameters, right? What will be my model parameters? I will define here my model parameters, model params, that is the parameters that will, on which it will learn. That is w1, it will have w2, right? It will have w3, it will have bias, and it will have is total error. That is the total error that we have, the net error that we have, right? And then we will have is learning rate, whatever the learning rate we choose. Model parameters, we have learning rate, sorry, keep it here. Learning rate, okay. I'll keep this as 0 and 0. I'll start with 0, or you can start with any random number. 0, bias also 0. Learning rate, I'll take something as 0.001, right? I can take any learning rate as of now. Okay, I have this. All right. So here we have. Now we need the predicted price, right? So predicted price is actually the same formula that we had, right? And the formula goes that, let's write down the formula. Predicted price, it was W1, that is basically is equal to I, this is I2 into W1 into A2, A2 plus I3 into B2, sorry, plus I3 into B2 plus I I3 into I3 into, this is my I3. Okay, I3 is already, sorry, it should be I4 into, first I'll write this B and C2 I3 into, it should be I4 into C2, right? And if I want to add any bias, if I have bias, I can add, right? I can keep it as it is also, right? So as of now, I will keep it as it is, right? So this is what it is, and I will just copy it to all of them. I'll copy it here. Done. Next part is obviously I have not yet predicted, so nothing is going to be here. Next part is my error part. So I'll have to add my error. So my error is actually going to be predict E2 minus D2. First E2 minus D2. Sorry, E2 minus D2. E2 minus D2, that is predicted minus actual, right? This is what my error is going to be. And what I'll do is I will copy it. Done. As of now, it is showing some value. Then squared error, I am just trying to square my error, right? In the sense I'm trying to penalize it more, right? Is equal to f to raised to the power mm, 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 is basically going to be this one raised to the power 2, right? And that's it. Sorry, I'm done. Obviously, two huge values as of now, right? Now, next, what should happen is basically it should actually go ahead and update these weights step by step based on learning rate. So this is what the Excel is. So what it will do is it will go ahead and update these errors and squared errors, and it will start updating the predicted price. What will be the predicted price? So all of this process starts happening, and then this weight is updated here, right? Weight will be updated here, and then this weight should be uh, basically the predicted price will be there. Based on predicted price, the error will be there, and then from this error this weight will be updated. So basically what I have done is just to automate this whole process so that step by step all of this thing gets automated, right? I will just I have just added a small loop script. Now, please do not get confused. You can do it manually also, one by one. But yes, obviously, when doing for 50 columns manually, it will take a lot of time, right? So I had to automate it so that at least we reach at some point, we are able to see some result. So basically, what I have done, I have simply added a script here, or there is one more actually. I do not know. There is one extension that is available in add-ons. If you see, there is one extension, it is called as player extension. That extension is actually blocked for me because this is a company account. I do not know if it is blocked due to, or there might be some policies, I do not know. I'll have to go and check. So there is one more. If you do not want to add any script, there is an automatically add-on available. So using that add-on, obviously you can do the same thing. It will go ahead and execute all of these things in the loop, or else I'll have to go to all of these things one by one. So I'll just go to extensions and app script, and I got this script online itself. I just made some small modifications, and I did not write it completely myself. So yeah, I mean, please do not be surprised. These are some scripts that are easily available on Google. You can go to ChatGPT to get these scripts. These are some very small scripts, simple automation scripts, right? And okay, basically what my script has done, it has simply added a new icon so that I can play. When I go and add, okay, okay, this has done. It has. done for this thing. I'll go ahead and I'll run for 100 steps. Okay, I do not know why it is not doing it for all of them. I think so. The formula is already there.
No, because I think the weights are not against all the cells, right? It might be
Maybe.
going backward by rates. Yeah.
Yeah. That might be the reason. And the error is exploding up. The error has exploded up. There is a bug in the calculation actually. Yeah, I'll stop it here itself. Reset weights. Oh, it is not just stopping. Okay. I guess I have some bug in the script. I will fix it and I'll provide it to you basically. So the whole idea being reset weights to 0. Yeah, the weights are reset to 0. So the whole idea being that we need to actually go ahead and update all of these things so that it keeps on happening. All of the data keeps on updating and total error and learning rate and all of those things. Maybe the learning rate was too huge. Even then, I guess it should not explode, even if the learning rate was too huge, right? So the idea being that, yeah, obviously what will happen, it will go ahead and it will keep on updating. The formula remains the same, whatever we have used, I guess. Formula has been added.
No, I think uh, I2, I3, I4 should be constant. So it is I7 should not be there in the seventh line. So just change the uh, put the dollar against I and
Yeah. You got it right. Yeah. That's exactly. I'll have to fix it. Basically, there is a expression so that these remain the constant. There is a specific expression so that these remain. Thanks, Dhaval. Uh, there is the expression so that these remain the constant and it does not changes. So what is happening basically, if I do not add the dollar sign, what is happening is it will keep on updating and it does not keeps all of these things constant. Yeah, that being the thing. So yeah, I'll update this script. We will go to a demonstration, basically the same demonstration, wherein we will try to see that what is happening, and then we will basically see that. Just give me a second. Okay, so right. So basically, again, the same thing. I have taken some small data set right here, and again, I will try to start learning, right? And it has also blasted. Mm, oh, learning rate and again, weight is also fine. Initial weight and bias is also fine.
Anand,
Yeah,
just
yeah, yeah.
one doubt. Like one epoch is running the training for all the entries once, right?
Correct,
So
correct, correct.
so at the end of one epoch, it has learned some value of weights.
Right.
And what is it is changing in the second epoch so that it learns better?
So in the second epoch, again, it will be new predicted value, right? There will be new
Because
prediction.
data is still the same.
Data is
Okay,
still the same.
okay,
Yeah.
prediction it will be different based on the weight it has learned from the
Weight
previous epoch.
and based on the error it is having, right?
Okay.
Based on the current error it is having, it is not actually the initial error, current error is too high. I guess in the script itself, this was a mistake that I did. The initial error was too high and the data is too small for this. Current bias, I'm taking all of these things and my error is too high. Even if I do this, what happens actually, the value becomes too huge. It is infinity. It goes, and soon it goes out of learning. I'll have to change this. Anyways. Mm. Yeah, I'll have to change it. It has basically there is no bug, but these kind of things, what happen if the parameters are not optimal? These values are not optimal, basically. Then what happens? My current error, I did this took it from this thing only, and these values are not the optimal values. Either I should have initial current error, I should have made it configurable so we could have played with it. But I guess I'll have to go and change the script itself. So the idea is that what happens as we start learning, this should keep on learning these parameters, and as it learns these parameters, basically what happens gradually, it will actually start all of these. Uh, the error will come down, and as the error comes down, our prediction and our actual values are very close to each other. Now I already have one complete working demo. Just give me a second.
Anand, like in the Google sheet, there was another parameter called total error or something. So
Total error. Yeah.
how are
That is
we?
average. That is average of, that is just to get an idea that how low my error is.
Mhm. Okay.
Now, okay, just give me a second. Let me run this thing only. Let me fix this thing so that at least we can have a look at it, what is going on. Hmm. Mm, I'll just reshare. Just give me a second. Okay. I have actually one working model present already, and where that this error has been rectified. I'll just share that one instead of we trying to rebuild the whole thing. Yeah. Let me open that. Yeah. So basically it is the same thing. I will just reset the weights. So here my weights are being reset, and the only difference is basically the formula is actually the same. Just we are using this dollar sign here. So what this dollar actually does is it makes these values constant. It is not updating every time. And then what I will try to do is it is the same script basically. I will try to run with one learning step, and this is my learning rate, which is much smaller. And I will, if I do it for one step, see, this is just for one step, and this is my error. Error is still very huge, and my weights have learned, and I can just run it for, and if you see the predicted price and actual price are getting closer, and if I just run it for 100 steps, it has started learning. It will take a while. It will take a while, and
So Anand, so
yeah,
how
yeah.
does this script predict the weights?
No, 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 no. Script is just automating it. The, the weights are all done using the formula that we already have.
Okay.
right? It is already updating the formula.
But we didn't put any formula for weights.
No. We have all the formulas here. You see, I'll show you. Okay, you are trying to say that how these weights are updated, right?
Yes.
Yeah, exactly. So for these weights, what we are trying to do that whatever our learning rate is there, learning rate into my error is there, right? That gets updated into the new weight.
Okay.
So the simple formula is simple multiplication. I mean, there is no such very complex thing. And based on how much you want to penalize it, how much the weight you want to update, so you can do that. Now, it is not that these numbers are fixed. See, is all happening because of the nature of the numbers. The nature of the numbers is that you can square it and you can have that what happens after squaring it, right? You can I will give this whole sheet to everyone so that everyone can play, and there is a script also along with it, so you can just go to extension and app script and you can just use it. You can just use it, right? So I will give all of these things to you now. uh, this is happening because of the nature of the numbers. You can just go ahead and you can have small modification in the number also. You can have small modification in the updation of the weights. It will still work. I mean, it may not work as perfectly. Now what I am telling you, is it the case that is it something written in the book? Not really, actually. I also, when I prepare for these things, I prepare this data, I do not even look at any book, in the sense that I just use some optimal numbers. I obviously take help of ChatGPT and Gemini to come generate these numbers and to come up with these numbers, right? So these formulas are some very simple formulas of updating the weights using multiplication and using subtraction and division. That's it. This is what is happening, right? Now, I have actually written the weight formula here also. If you just want, I will 3D weights visualization. This is one weight, just epoch train program run. House visualization protection. Formula for weight was present. I did write in some one of the visualizations also for reference. Uh, actual price and
So that formula must be there in the script itself, right?
yeah, that is I just wanted to show you in the visual manner that is definitely present in the script also, and it is a simple multiplication thing. It's nothing. Now it was actually present in all of the previous ones also. If you see, even in this one it was present. Even here also it was present. If you see, even this thing, so weights is W1, W2, W3. The formula is present, updating is happening, and learning rate into error into X1, right? And this is what W1 is getting updated. W2 is learning. This new symbol is actually learning rate. This is the learning rate symbol, right? Into E into X2, right? And then learning rate into E into X3. So I mean, it is not a very complex formula. It is not something extremely square root or under the nothing like that. Nothing like. In fact, none of the formulas that we'll discover in future will be like that. In fact, even if they are, so I'll be breaking down that into so simpler format that you will feel that okay, this is just a very simple mathematics, right? Okay, so it has finished, and finally what we have is, if you see my actual and predicted values, where we are in actual and predicted values. Let me uh, plot between actual and predicted values. How far are my actual and predicted values? Okay, actual and predicted, it is showing this way, but I'm not sure which circle. Predicted price and actual price is this. Actual and predicted should be with different colors. No, it is still, but yeah, I mean, if you see these are still present, you can just plot it yourself also, actual and predicted. But I guess these dots that are very close to each other, these might be there, actual and predicted one. Uh, Ideally, what I wanted that both of these colors should be different so that we can see that our actual and predicted are now very close to each other. So if we try to predict the house prices using these simple bedrooms, age, and all of these things, so we very simple formula, no GPUs involved, nothing involved, we will be able to make somewhat close prediction. And as we go ahead and increase the number of parameters, as we go ahead and increase the number of parameters, what we start seeing is that uh, we start seeing that all of these parameters, uh, I mean, even the complex relationship, it is able to learn. Now this relationship may not be linear here. In this case, obviously this is linear, but yeah, this linear was not just because there is bedroom, there is age, there is actual price. So all of those if else conditions and all of those things it has learned, all of those complex edges condition. We did see that in the previous temperature thing, the data was present in form of sine wave, right? It was not this simple straight line. So that specific sine wave, either you find out the formula of that sine wave and then you do it, and many a times the data will be even more complex. Like sometimes the data will be in first quarter, the data is in sine wave. In second quarter, the data is making a lower side curve, but in third quarter the data is making an upper side curve. So and this thing is actually close to, I won't say impossible, but actually very difficult to put all of these such complex formulas in rules. So at that point, even the simple weighted learning algorithm can actually do the job. Obviously, as we go forward, there are more algorithms that we can use, right? There are many frameworks that we can simply use to fit all of these things. Now, doing this thing in Python is hardly 7 to 8 lines of code, right? I mean, many of you might also be knowing Scikit-learn. Using Scikit-learn, you can do all of those things. Yeah, but as we go ahead, for images, for videos, obviously Scikit-learn does not work. Then we lean on to a new framework called as PyTorch. PyTorch is the same framework on which ChatGPT is built, on which Gemini is built, on which Anthropic is built. In fact, all of the startups of the recent times are built on PyTorch. Right? PyTorch is the go-to framework for all the AI, all the future research happening in AI. So we will be using finally PyTorch. We'll start. We started with Excel. We'll jump to Scikit-learn for a few problems, and then gradually we will jump onto PyTorch. The end will be PyTorch, and in the end, along with PyTorch, few extensions will be present like that of LangChain, etc., and all those things. There is one more example that I wanted to cover. Just let me open it. Let me see where it is. Just give me a second. Yeah. So here is one more data that we have. Now here is one more data that we have. Again, the data is a bit more complex, and I did not actually study around it more because I mean to prepare even all of these data, it took me a lot amount of time. So we have acres, we have district. This time we have district city, and this time we have district amenities, right? Distance from the city. It is distance from the city. It is distance from the amenities. This is air pollution, right? And this is crime rate. This is my actual price, and this is the size of my house. So basically, now the data has grown even more complex. When it has grown even more complex, so if we try to find out the relationship, so create, this time I will show you somewhat different. Create a histogram. I do not know this will create a histogram or not, but let me try. Create a histogram of correlation of of acres, distance, city, distance, amenities, and air pollution and crime rate with actual price. Let's see if it is able to create one. If not, then we do have, no, this is not the right histogram. This is a faulty one. Correlation thing is there, but number of features is this, no, for every feature I should get maximum of actual price, right? Okay, plot. So basically a histogram is basically a chart wherein we can see the relationship of actual price. If it is closely related, if it is inversely related, what is the relation? That is only a direct relation, right? That is only a direct relation. Now, even if the relationship is not present, right, in future, it does not mean it should not be kept. In future, we will see that in neural networks, even if the relationship is not present, our AI will learn automatically to sideline that feature. These all are my features, right? It will learn automatically to sideline the feature. So plot between, we already know acres, distance, distance, city, and actual price. Okay, there is no linear relationship actually. So what is happening? The price is increasing as the distance is increasing from the city center, and then at one point the price stagnates with the distance, and then it is coming down. So it is a curve that it has made, right? And what is the relationship with air pollution, I think, or with the crime rate? Plot crime rate with actual price. This is also somewhat that if the crime rate is increasing, obviously this is an inverse relationship, not a direct inverse. And this is how the real data exists. The real data does not comes in straight lines. It does not comes in well-defined curves, right? This is how the real data is, right? The crime rate is actually inversely related, but yes, I mean this inverse relationship is also not very straightforward. And then we have air pollution, relation between air pollution and actual price. Right. And again, this is again inverse as expected. These all are inverse except for this one is semi-inverse. First it increases and then it decreases. This is uh, a kind of curve it is making, right? So and then obviously acres and actual price is having a linear relationship. Now we want to mix all of them, and then it should come up wherever the right prices are there. It should come up with the right thing, right? So this thing we will, although we know that how using weights and everything we have done it, uh, try to solve it first yourself, right? And then we will solve it here in the sheet itself in the next one, in the next session. We'll solve it right here step by step. We'll spend some 10-15 minutes in solving them. And second part being that second in the new week, a weekend, what we'll see is we will start seeing how to convert these both programs into automated scripts, simple scripts, 4, 5, 8, 10 lines of script. I mean, nothing more. If you know these formulas of Excel, these are very simple formulas of Python, that we will be seeing. I just have one last demonstration to show, and it is around the same thing. Right. I guess it was the same. It was the previous one only. Right. So yeah, basically this is one to do thing for you. So you can just take the help of Gemini and everything, and then Gemini can help you in writing all of these formulas and everything, and it can help you in writing all of those functions. It will be pretty easy actually. You can pretty easily, and I will share this whole script with you so that actually if you want to modify the script you can do that, or else you can use the extension that I told you. You can use that extension for it, and even if you are not able to do it, that is okay. Just doing it for first 5 columns will also work, right? Just because that will give you an idea that what it is working on. Just doing it for first 5 columns will do the job. You will be experimenting how the weights are updated and everything. You will be experimenting with all of those things, and what I will do in the meanwhile, by tomorrow I will post the solution also. I will post the exact solution, what to update, where to update, right, with the right columns and everything. You just have to see that, and you just have to replicate that solution. So I will also have to prepare that solution and document it, and you just have to go ahead and see that, okay, at J there is learning rate, at J2 there is weights. So you just have to go and do that thing. That's it. So this will actually help you in understanding that, what is happening, how these weights are getting updated and all of those things. And then next we will actually get hold of the more advanced concepts. We'll see few more. Next week is will be actually some more important things. We will be actually covering over one very important topic that I actually did not cover in the previous batch, and that is how to deal with tabular data, specifically with tabular data, because I see there is a lot of tabular data around us. This is also tabular data, right? This is also tabular data. So on top of this, we will add one more condition, that is random forest. We will add how to use random forest and XGBoost, if you are able to cover that in the 2 days of session. So basically how specialized tabular data should be seen, what is the best way, and it is not an outdated method. Many so-called AI experts, they call that this is an outdated method. Not at all. XGBoost is very uh, I mean, those who know how to use it, it is used at many places. All the tabular data is getting done by XGBoost and all of those things itself. Right. Okay. All right, guys. So I guess have a nice Sunday ahead. And any questions? I'm up for any questions.
Yeah, Anand, you'll be posting this in, or you'll be sharing the link of this data?
I'll post it in the WhatsApp group
Okay.
along with the videos and everything.
Okay, perfect. Yeah, thank you.
Right. Right.
Anand, just
Yeah.
quick question.
Yeah.
So
Yeah. Yeah.
we build this prediction, right, in the
Right.
Excel. So
Right. Right.
we
Right.
use this then because this is itself a small model, right? So can we use this further to predict new price, right? So so how can we use it?
So, uh, like as I know in industry,
Mhm.
uh, I mean, 3, 4 years back, a lot of prediction was done on Excel, right? Using these simple formulas.
Mhm.
We will go ahead and we will see that using the same formula, there is one thing called as linear regression. Using the same formula, there is one more thing called as logistic regression.
Mhm.
Linear regression and logistic regression till date, even till date, they are used in 60% of business applications. 60%. This Tableau, right?
Mhm.
Tableau is somewhat advanced version of this only,
Mhm.
right? What we all of these linear regression lines, logistic regression lines, and XGBoost, just these three. So all of the data analysts are working on these, most of around these things only. Now, yes, you can use Excel for prediction, right? But yes, I mean, obviously, when you do it through a script, when you do it through a Python script, it becomes more robust. It becomes more UI friendly, right? It becomes, I mean, it is, you can deploy it somewhere. It can be integrated along with some other application, right? If you have some Salesforce or other application, you can integrate it with that application, right? So integration becomes easy. So basically, it becomes a piece of a software.
Yeah.
So that is the advantage. And obviously, very complex models cannot be modeled in Excel, right? Up to certain extent, even Monte Carlo simulation is one thing that is again very much used in credit risk finding. And before issuing you a credit card or not, all the offers that are made to you is because your credit score and your previous payment histories and which payment history has defaulted is present with all the banks. It is a paid uh, data. You can purchase it. You, even if you want to open your own credit card company, you can purchase it. And these companies basically, they want that someone who has been paying their credit cards properly, we want to sell credit card to them. All of and this is a booming business right now. You see, very there are companies just they're not banking solutions. They're just credit card solution. They will give you credit card for food items. They will give you credit card just for travels. They will give you credit card just for XYZ, just for specialized things, right? Because this is their business model, and then they charge you hefty things because they know that you are a kind person, and so yeah. Even before issuing any insurance to not just person to any airlines, so I did talk to one person. They used to, and it was from an insurance company, they used to issue their insurance to an airline company, right? And their job was to issue insurance to Malaysian Airlines, basically with the Malaysian Airlines, that 161 171, those two airlines, they were not known. So basically, uh, so I got connected to the person who denied insurance to that airline that met with the crash. In it basically it went into uh, Australian Ocean. I mean, I do not know the right name. So right, so it went there, and I was talking to that person. I mean, luckily we were distant friends. So he was telling me. I started asking him, so how do you model? So he told me that we model using Excel itself. So all of the data is present using Excel, and we use linear logistic and all of these regression we run on Excel itself. And this there is, but this is again, the story is 4 years old. Down the line, everyone has started using at least Python or at least Tableau. All of these tools have become prominent, and now even Excel have started supporting Python. So just like this app script I'm trying to add, even Excel supports Python. So yeah, right. All right, guys. Okay, then have a nice day ahead. Bye, and I'll catch you. I'll post all of these items and everything into the group, right? By maybe tomorrow, I'll post, right? All right.
Thank you.
All
Have a
right.
nice
Thank you. Thank you.
Bye. Bye,
Thank
guys.
you.
Bye.
Thank you.